Okay, so we're going to take 5.6, which is about finding rational zeros, and we're going to break it up over a couple of lessons because there's a lot of stuff in here. So rational zeros, the word rational is referring to a certain kind of numbers. I think that we've talked about a kind of numbers that are rational numbers. Do you remember those? Good. All right, so objective one in this lesson, be able to find zeros of a polynomial function. Where are zeros? Where are the zeros of a polynomial function? They are the x-intercepts, usually, unless they're imaginary. Okay, objective two, use the rational zero theorem to find some possible rational zeros of polynomial functions. Okay, so that seems like a lot of words right in there, but don't worry, when we get to objective two, it will totally make sense to you. So objective one here, you're going to be able to find zeros of polynomial function. So I've chosen this picture of these snow drifts just because the snow drifts are the snow dunes make this very nice smooth curves. Those very nice smooth curves are exactly what polynomial graphs look like. And then I threw in that line right there as that white line as like an x-axis, and we're trying to see where our graph would touch the x-axis. That's what the zeros are. This is assuming, of course, that they are real numbers, because if they're imaginary, they're not going to touch it. Okay, so let's take a look at this first exercise. Use synthetic division to divide, and then I have a polynomial function, and we're going to divide it by x minus 3. So when I divide this by x minus 3, remember, this is lying to us, so we're actually going to divide this by 3. So we'll put 3 on the outside of the box. Across the top, am I missing any terms? I got x cubed, x squared, x. Nope, doesn't look like it. So we have a 2, a negative 11, a 3, and a 36. All right, now I'm going to bring down my 2. Multiply here, I get 6. Add negative 5. Multiply negative 15. Add negative 12. Multiply negative 36. Oh, look at this. 0. That's the remainder, of course. And what does that mean? If I have a remainder of 0, this means that x minus 3 is a factor of 2x cubed minus 11x squared plus 3x plus 36. It goes in evenly. What this means is I can rewrite this function like this. F of x is equal to x minus 3 in parentheses. And the other one is coming from what I got from the synthetic division. 2x squared minus 5x minus 12. What we've just done is we have factored that polynomial. All right, and that's pretty much what we're going to have to do here in order to find our zeros. So since the remainder was 0, when we divided by x minus 3, you can rewrite this like this. So on the left-hand side, you have a division problem, as in my original function, 2x cubed minus 11x squared plus 3x plus 36, I'm dividing it by x minus 3, is equal to that quotient, this what we got whenever we did the synthetic division. Okay, so if I multiply both sides by x minus 3, it gets rid of it over here. I'd get rid of it over here, and then just multiply it over there on the right-hand side. So it's showing you that we basically are able to factor our polynomial. Right? Okay. Right. It's a factor. Exactly. Okay. So this is called the factor theorem. Polynomial f of x, just like the one that we were doing before, has a factor x minus k if and only if f of k is equal to 0. If we combine this with the remainder theorem, what this means, let me go back a couple of slides here. If I divide by that 3, I get a remainder of 0. So that means that f of 3 is equal to 0. It's a 0 of the function, and you can use it to factor. So x minus k would be a factor of that polynomial. So this theorem is going to be able to help us factor and solve polynomial functions, but it's only really helpful if you already know one of the factors. And so at the very beginning here, that's what we had. We had one of the factors to begin with, and then we could factor the rest of it, okay, by synthetic division. So this is the same exact problem as before. Now what I want to do is go ahead and finish factoring it, and then find the zeros of that function. So we had already said that we can rewrite this f of x as x minus 3 times, I believe it was 2x squared minus 5x minus 12. Okay? So the x minus 3 is already prime. We don't have to do anything with it. We just have to factor the quadratic that's left over. So I'm going to bring this part down and then open up my parentheses for the rest of the stuff. And whenever I go to factor this, I need a 2x here and an x here so I can get 2x squared. This times this has to be negative 12, and then whenever I go to FOIL it out, it's got to add up to negative 5. So let's just try some things here. If they don't work, we can go back and erase it and change it to something else. How about I put a, let's see, a 3 and a 4? You want to try a 3 and a 4? That sounds pretty good. I'm going to put a 3 here and I put a 4 there. We've talked about why you wouldn't put a 4 inside with a 2, because then it would have a common factor of 2, which meant that you could have factored out a 2 to begin with from the original equation. So let's see if this works. I would have a 3x there. On the outside, I would have an 8x. Can I do something with that to get 5x? Sure. I just need this one to be negative and this one to be positive. So this is already factored. If I set this thing equal to 0, then my zeros are x equals 3 from the first factor. From the second one, I would subtract the 3 over, divide by 2. It's negative 3 halves. And for the last one, it's 4. Ta-da! And that's the goal here for this lesson, to be able to take one of the factors, divide it out, get something that might be quadratic, and then factor it as usual. After you get it all factored, then find out what are the zeros for that function. Okay, so factoring this one wasn't too terrible because we already knew one of the factors, right? Right. However, you're not always going to know one of the factors. So the question is what are you supposed to do if you don't have a place to start? What factors do you start with? If it's a cubic one, you don't just open up 3 set of parentheses and then try to factor it like that. So that's what the rest of this lesson and the next lesson is going to be addressing, is how are we going to get that initial factor that we could divide out and get to factoring. Okay, so now what I want you to do is go through the exercises in the next video.